and loading and uploading is concerned, you can have this kind of so-called brief of the cable, and this at the end of the cable system, that is the place where you have the cable termination, or even more important, whenever you have joints, these are kilograms that the copper of the or the aluminum pushes against your accessory. And this, believe me, is one of the most severe causes of failure in accessories along the real life, and of course along a pre-qualification test simulation. Talking about the pre-qualification test, the assembly will be heated by the conductor current only until the cable conductor reaches a temperature of 0 to 5 centigrades above the maximum conductor temperature in normal operation. For example, for XLP, we're talking about 90 degrees, but can be also lower. The heating arrangement selected so that the cable conductor attains a temperature specified above, remote from the accessory. So this measurement, the heating arrangement should be remote from the accessory. The surface of the cable should be recorded for comparison purpose with the information coming from the dummy cable, or so-called image loop. Of course, the dummy section replicates the temperature measurement on the cable sheet, but on a different sample of the same cable with the same laying condition, but no voltage is applied. Of course, this is the big difference. In a dummy cable, we can drill up to the conductor and install the thermocouple on the conductor because we do not apply the voltage. We have the same current circulating. We measure on the conductor, we measure on the cable sheet, so we gain the so-called thermal drop. That is the difference between the temperature on the cable sheet compared to the temperature on the cable conductor. This difference is named thermal drop, and we have the measurement coming from the real cable that is under voltage, where we only can measure the temperature on the cable sheet. This temperature should be very close one to the other, and we use this thermal drop in order to increase or reduce the current circulation in order to be on the tolerance of 0 to 5 Kelvin for the maximum conductor temperature. Normally, the heating is applied for 16 hours, and the conductor temperature is maintained with the stated temperature limit for at least 2 hours, of each heating period. Then we allow 32 hours of natural cooling. We have to apply the voltage at 1.7 U0 for the whole test period. That means 8,760 hours. And taking into account this 42-hour cycling, the cycles of heating and cooling should be applied at least 180 times. During this 180 times, no breakdown shall occur. This is a must. I put here an example of this of a temperature of cable, a diagram of the temperature during a pre-qualification test. You can see that there are different colors. The lower one are related to laying situation whenever you do not have a so-called hotspot. Normally, the hotspot is in the pipeline. Why? Because, of course, the pipe is is a small one compared to the dissipation you can have in the earth or in a tunnel. So the highest temperature value is reached in the pipeline area. Sometimes there are some utilities, some power system operators that in case of a special situation, they need additional load to be applied, for example, during emergency service. And so they want, at the end of the 180 cycles, they want to apply this so-called additional load cycling, for example, at 105 degrees centigrade, in order to verify the emergency operating temperature for XLPE insulating cables. For example, in Europe, Terna from Italy or RTE from France are used to ask for this additional emergency service loads. And the same is also applied by some American utilities. In the USA, it's even worse. Some utilities ask for 90 heating cycles in a normal ISC situation, so up to 90 degrees centigrade for XLPE, but another 90 cycles at the emergency level, for example, 105 or 110 degrees centigrade. Let me show this is very important diagram to have a better understanding of a cable system situation. Let's start from the left. On the left, you have the cable termination. This is a platform that is put outside. You can see here that there are two different colors of cable termination. It's because I consider one porcelain, or this is the light brown, and one gray for silicon. And this is normal the solution that cable manufacturer applied in order to qualify both solutions, because it means that during one test you can qualify different cable termination design. Then we go under the soil to reach the. Of course, here you can see some pictures taken on a real cable system laying situation. Going down in the soil, we have joints that are installed in the joint bay. Of course, this area then will be covered by soil, but for the time being, I use this picture to show you the real situation. Then, then we have the pipeline. The pipeline, as I told you, is the place where we will have the hotspot. That means that the temperature we will reach here, this pipeline that normally is about, it's a pipe from 10 to 12 meters long, with a diameter from 20 to 30 something centimeter. Sometimes we installed also some insulation material in order to have a better temperature distribution, but this really depends on the utilities. Someone want to use it, someone not. So this really depends on our customer. What is very important here is it's that you understand this is the dummy cable. The dummy cable has the peculiarity to be not on voltage, of course, in order to measure the thermal drop, as I told you, but it's very important that very important that the dummy cable has the same layout condition. So going into the soil, then enter the pipeline, then going back to the dummy area. That's why if we think about the length of cable we used for a pre-qualification test, for example, talking about type test, 40 to 50 meters are enough, plus 5 to 10 meters for the dummy cable. If we talk about the pre-qualification test, you need to have more than 100 meters. I suggest at least 150 meters, plus at least another 50 meters for the cable, for the dummy cable, in order to be put in the same layout condition. Here you have example of a tunnel. This is a very special tunnel we use in Milan for the first time ever in the early 90s to test the first 400 kV XRPE cable system ever tested in the history for the BEWAG project. BEWAG was the Berlin Utilities. So this is a very special tunnel where we have two main sections. One real tunnel plus a bunker where we can install the back-to-back situation. For example, here you can see we have a back-to-back in horizontal connection instead of in a double horizontal connection instead of a single one. So now I would like to introduce a special test because not only type test and pre-qualification test are asked by utilities, but more and more in the last years, we got a request for testing also in other testing configurations. Some of them are already introduced in a standard, in an international standard. Some of them are only requested by some utilities, so you can find only on their own technical specification. These, for example, are internal arc test or pollution test or on cable termination, and short circuit test on cable accessories. Why utilities all around the world, not only in Europe, also in the Middle East, in USA recently, we discussed it also in China and so on, why they are asking for this special test. The main drivers are the major outages that ask for the implementation of more stringent regulation in the level of quality supply in main countries. This situation pushes utilities to look for the evidence of testing to demonstrate they work with due diligence in choosing equipment and technologies. For example, let me talk about the picture on the left, internal arc. Here you can see the facility we have in Milan. This is one friend of mine during nighttime, because these tests are performed only during nighttime. I will tell you why in a while. Trying to extinguish the fire that was caught on top of a cable termination. Why we perform this test during nighttime? There are many reasons. These are explosive tests. So during this test, you may have explosion. In this case, it was not the case because this was a silicon cable termination. But in case of porcelain cable termination, believe me, you can have debris all around. I remember one of the first tests that we performed on a 400 kV porcelain cable termination. At that time, we do not have yet this configuration like a tower where we installed internally the cable termination. Then we have a tank on the bottom to collect the oil, and all the debris in case should remain inside, or with the only opening can go outside, but not more than 3 meters from the cable termination. This is a must for the main cable specification. Why we perform during nighttime? As I told you, because this explosion can be very dangerous, a lot of noise, but a lot of danger. I was saying that during the first test, we found a piece of about 500 grams, so half a kilo, of porcelain about 200 meters far away from where we had the explosion. So imagine if you do it at daytime when people is going around, you kill people. And that is also the main reason why utilities want to have this test being performed, to be sure that there are this explosion, so-called explosion-proof solution, because in case of urban high voltage substation where you have a porcelain cable termination, you need to avoid, it's a must to avoid this kind of explosion in order to save life and to reduce the danger to all other equipment in the substation. This is the main reason. Second reason, it's a practical reason, because in order to deliver this test that normally are performed from 30 kiloamps up to 80 kiloamps up to 3 seconds, in order to deliver such a power, Terna, that is the Italian utility, allowed us to have this connection only during nighttime in order to avoid any kind of blackout in Milano area. That's the real reason. Let's talk about a less dangerous special test, pollution. It's less dangerous because, of course, in this case, we do not have explosion, but for sure, it's of great importance for cable termination. These are pictures taken in our Mannheim pollution test chamber. We test both HVAC up to 600 kV or HVDC up to 500 kV cable termination. In this case, you can find a loop that was also with a cable joint because it was part of a special test for a utility. But pollution is also important, especially in the Middle East area, where you may have a lot of sands that can be collected, especially on porcelain, but even more dangerous in composite, where you can have also some kind of interaction with the composite material and have a high penetration also in the shells. But also it's important not only in desert area, but also in coastal areas. Whenever you have salt that deposit on the shells of the cable termination, so you need to be sure that the applied voltage will not create any flashover. And last but not least, also in heavy industrial areas, whenever the pollutants can deposit on cable termination, and so also in this case, it is not sand, it's not salt, but can be some chemicals that can be even more dangerous. Then a short circuit, of course, this is say more normal for our electrotechnical understanding. This is, for example, this test was performed for a Middle East utility in Milan of 400 kV cable connection. They want to verify is the connection that was designed up to 40 kiloamps, as far as I remember, 1 second. These accessories can withstand this short circuit situation in order to prevent problem during the real installation of the cable system. Then I also put examination, because examination is very important for whatever the test we are talking about. Type test, pre-qualification test, explosion-proof test, pollution test, short circuit test. At the end of the test, of course, it's a must to fulfill the requirements of the test, but also examination should not present any deterioration that can create problem during a normal operation. This is a very short sentence, but very dangerous, because without any example, you can start a discussion with the inspector who witness the test, and you are lost. That's why we in STL is the circuit testing liaison. In the cable group, I am a member also of this cable group. We introduce a suggestion on how to deal during examination in order to help people and avoid never-ending discussion with inspectors. And this list has already been introduced in the new revision of 6840 that will be published hopefully this year. We recently started a revision also 62067, and of course we will introduce the same list also in the next revision of the 62067. Failure analysis. Failure analysis is another, I put in the section special test, even if it's not a special test, it's a special services, but it's more and more requested by our clients. Why? Because when a failure happens, normally you have a discussion starting between the manufacturer of the cable or of the accessories and the end user to find the guilty guy. Someone said that your design is a very poor and weak design. You are the guilty guy. You have to change everything at your own expenses. Vice versa, the manufacturer is saying, no, it's you that apply a procedure very much different from what we designed. You have changed your requirements along the route, and now you are in trouble. It's not because of my design. That's why Chasey and Chemalabs are requested to deliver a failure analysis from a third-party point of view. We act like a referee. In fact, we do not gain any money in selling more cables or joints, and we do not sell electricity. So we do not gain any money in selling electricity. For us, the client would like to have our expertise as a referee, and based on a large database of design review, past experiences, and know-how of experienced personnel, we deliver failure analysis report to our clients. For example, a common way of failure in a cable or accessories, an example to perform a failure analysis is to compare the sample who have suffered a failure with a sample that is still without any failure. Of course, we need all the manufacturer specification in order to verify if the mounting of the cable termination or of the cable joint was done properly. An important information is given again by the visual inspection in a review of all the tracks and all the operation performed. Apart from the visual inspection, further tests can be implemented. For example, mechanical and chemical analysis on the insulation and on the sheet. Basically on these two main components, because semiconductors are difficult to examine, some of them or most of them are not peelable. And this further mechanical and chemical analysis will help us to define the most probable cause of fault. For example, traction, this measurement of the mechanical characteristic is done on the cable sample and insulation on the sample failed and not failed. Then digital scan calorimeter, SEM, thermogravimetric evaluation of physical and chemical characteristic of the sheeted insulation is performed on sample fade or not. And this allows us to highlight any symptoms of misuse, for example, accelerating aging due to overstress, on the object in terms of load current presenting sign, as I said, of accelerating aging, is a result of overheating during normal operation. I put here two examples of discharge. The one on the left is an example of a radial discharge. Radial because the flashover went from the shield, that is just under the sheet, directly towards the conductor. So this is a radial. And this is an example mainly due to electrical problems. Vice versa, on the right side, you have a longitudinal discharge. That means that this path is along the length of the cable. That is mainly due to humidity, penetration, or similar chemical penetration of this kind. So I hope that everything is clear so far, but if not, please send me along the chat section your request for clarification or your email. I will try to clarify later on. Let me just drink a little of water. So, what are the critical issues when testing high voltage cable? I put a short list trying to include the typical tests to be performed on a high voltage cable system, giving a rationale for the best of the critical issue, I name it CI, that can be associated with the test. For example, bending test. The bending test is the first test to be performed. This is performed to demonstrate the ability of the cable to withstand delivery in big drums and also to withstand the laying condition. And this is a stronger request for submarine cables. There are even tensile tests much more severe than this bending test. The critical issue is that some utilities accept only tests performed by third-party laboratories. We are used, vice versa, to deliver our inspector to the manufacturer premises. But in case, we can rent tools locally and perform it in our laboratory. Heating cycle voltage test. These are performed to simulate a real-life loading. So we have a voltage plus current application, and as I said, a dummy is used to determine the thermal drop. As I already said a couple of times, partial discharge tests are suggested to verify cable internal displacement. This can happen during production, accessory mounting failures, and accelerating aging process. The critical issue is that if you perform this measurement during a type test, okay, you can do it in a lab. But if you do it during a qualification test, the noise background is very critical. So in a lab, we cannot accept if a background noise level is greater than 5 picocoulomb. And during an on-site testing, a special attention has to be paid for a noise suppression. There are filters that can be used on the on-site because in that case there is no fixed value for the background noise. In case some utility, then after the heating cycles, we need lighting impulses or switching impulses in case we have system with the nominal voltage greater than 300 kV. These are performed to simulate the operating events or accidental events that the cable system can face during decades of real life in the network. Normally, these impulses are performed on about 30-meter samples in a high voltage hall, both in case of a type test and pre-qualification test. Of course, you always need a dummy to measure the thermal drop because the impulses has to be performed not in normal condition, but in hot condition. That means at the highest maximum temperature for the conductor. And this I put a special warning because in case of a utility ask to perform the test on a complete cable system, that is the 150 meters of the cable loop, you need to use an on-site impulse generator. And just for your reference, a couple of days of this on-site impulse generator, the renting is about 50,000 euro. And you are on site. It means that if you have rain, you have to stop, and another 2 days has to be considered, and so on and so on. Talking about critical issues during a special test. Of course, we must say that in this case, there are different approach and requirements from different end users. Internal arc tests are used to verify electrodynamics and explosion problem that can be generated when a failure happened inside a voltage cable termination. In this case, there are layout and ratings that has to be fixed by the client in agreement with the final end user. Pollution tests on accessories. These are used to verify the influence of environmental pollutants of the termination, as I said, marine, desert areas, or in the industrial plants. Also, in this case, special chambers and testing procedure that are applied may differ. Talking about a short circuit test to verify electrodynamics and thermal problems that may generate during a short circuit that happens in real network. This is done not only to check the cable, but also the accessories. And again, the layout and the ratings has to be fixed in agreement by our client and the end users. Okay, let me introduce a little bit AC and DC cable system. In the near future, in the near past, sorry, the HVDC cables system has been increased more and more, both in land and submarine interconnection. AC transmissions is used on short distances because it's more cost effective and does not require convert stations. Vice versa, DC transmission is used for long lengths. For bulk power transmission, max impregnated cables still prove to be most suitable solution because of their capacity to work up to 600 kV DC. But recent developments on converter technologies have led to the adoption of extruded insulation cable for DC transmission system up to 300 kV, but now even up to 500 kV. I use this picture to give you some ideas of the cable length of the interconnection that normally apply for the use of AC versus DC, and also the voltage level with the insulation material that is used comparing AC extruded AC fluid filler or DC extruded DC mesh impregnated NDC fluid filled. You can see that with the interconnection longer than 130 kilometers, it really depends from project to project and the cost associated. The DC cable connection is a must compared to AC because of the compensation you need. So this compensation, the compensation you need can be comparable to the increased cost of the converter and the complexity of the interconnection. So nowadays, for interconnection longer than 150 for sure kilometer, both land or submarine cable, the preferred solution is ADC cable interconnection. Then we can talk about the materials. Oil filled, for the time being, is still the preferred solution for very high voltage. For example, I'm thinking about a 600 kV interconnection in the UK, but also other interconnection around the world of this oil-filled cable. Mass impregnated is also very well accepted, but nowadays there is an increased interest of utilities to use extruded cable, extruded insulated solution because of the easiness of installation, because of the very low complexity of management compared to max impregnated and even worse oil-filled cable system, and so and so. So this is the main reason why this feature of extruded insulation cable will increase in the near future. Both AC and DC submarine cable, talking about submarine cable, I already mentioned, they need further mechanical testing due to the peculiarity of the ending of the cables. On the right side, there is a picture of a cable testing area that is located in Cesi, Milano, by the way, where special tests are carried out, tensile bending test, so-called, to simulate a cable installation from the ship and or the cable recovery from the bottom and repairing operation. This picture shows the bending and pulling line cable of pulling up to 200 tons. You have to consider that
मैं अगर नहीं आ पाए तो आप करा लोगे? नहीं, क्योंकि हम लोग ऑफिस के छुट्टी के दिन लॉकडाउन हो जाता है, बाकी दिन ऑफिस में फंस जाते हैं, चक्कर हो रहा है, तो चक्कर में तो हम आ ही नहीं पा रहे।
Yeah, I think is on.
Hello. Hello.
Yes.
We are not getting any voice.
Yeah, no audio is there. I think he has put it on mute by mistake. Lalitji, are you there?
can you hear me?
Yes, we can hear you now.
Okay, sorry.
Yeah, no problem.
I was saying that this tensile bending test is performed on cable system because it means that this submarine cable also includes a factory joint that has to have the same size of a cable. So in principle, the diameter should be the same and has to be tested with this strength in order to be sure that in case of shipping and installation, this will not create a problem. Of course, a repair joint, this cannot be tested because this has to be prepared on the ship. And again, this can be a weak point of the cable system. We can compare some critical issues between an AC PQ test and a DC long duration test or PQ test as you like. During an AC PQ test, each heating cycle is equal one to the other, and it is replicated 180 times. So in case of unforeseeable interruption, blackout, testing circuit maintenance, and so on, if you lost a cycle, you can add at the end of the test before going to the lighting impulse section. So sometimes instead of 1 year, the test lasts for 1 year and 1 week, 1 year and 10 days, 1 year and 3 days. But it's not a problem because you put the test to be performed at the end. Every cycle is equal one to the other, so no problem. Totally different situation for a long duration test in DC. Because unfortunately, here we have differences between polarities and load application. And this unfortunately prevents the use of the letter procedure, the one to put cycles at the end, and make the test itself, of course, more difficult to manage. In fact, if you look at this taken from ISA 62895 or SIGRE Technical Brochure 490, these are the load cycling to be, the 18 cycle to be applied for the long duration test. In this situation, if you look at the voltage source converter or the line commutator converter, in one case, you do not reverse the flux, the current flux, in the other you have to. But the main issue is that you have, for example, let's start from the first column on the left. There is a load cycle with 40 cycle with the polarity voltage. Then you have another 40 cycle with a different polarity voltage. Then you have 40 days with high load at positive polarity, 40 days at negative polarities, 120 days zero load, so no current circulation, only voltage. And then at the end, 40 cycles, load cycle with positive polarity and 40 cycle with negative polarity. You can see that for the line commutator converter, it is a little bit different procedure, but at the end of the day, there are again 180 cycles, but many differences between one and the other. So, for example, if you have a blackout, if you have a blackout in this situation, you have to stop, no way, until you have either solved your blackout, or if you have got a failure, repair whatever is failed and so on, and then you have to restart. You cannot just finish and say, okay, there was 1 day I have to enter for maintenance because there was a heating transformer that failed, so I have to change and so on. So it's not possible. And this is a big issue, believe me. It's a very big issue. Last but not least, to complicate during HVDC testing, at the end of the heating cycle section, in case of DC, we have a superimposed impulse testing that shall be carried out on the cable system as an acceptance test. And this is a complex procedure that is performed to assess the integrity of the cable system with DC applied, positive and negative, and impulses at different polarities, both positive and negative. As you can imagine, you can see also from the diagram you have on the right side that in case you can reach about 2000 million volt, sometimes plus or minus. Other voltages can be reduced in case we have different polarity and so on. But for sure, this is a complication compared to the only 10 plus, 10 minus lighting impulse or switching impulses to be performed after the HVAC test. These pictures are taken inside the laboratory in Mannheim, Germany, during one superimposed impulse test of a 525 kV cable system. I want to stress one very important peculiarity of this German TSO 525 kV cable system PQ test, that for the first time ever, the long duration test, the pre-qualification test on HVDC cables are not performed on the floor of a laboratory like the Cigarette Technical Brochure 495 or the IXA 62A95. Sorry, Technical Brochure 496 and the IXA 62A95. But mainly underground, representing the real network situation like urban tunnel, pipelines, and joint bay. If you remember, this layout is very close to the one that I already presented to you, also because we deliver it from Chile, by the way. But apart from that, here you have an outdoor termination bay that is inside the laboratory, that we go, you will see picture, we go under the soil of the laboratory. Then we go outdoor in this area, under the soil. Then we enter a tunnel. We installed this tunnel for each one of the cable manufacturer we tested. Here we have the heating transformers and a cable joint. Then we have a bent that of course is mandatory in the loop. Then we have another joint bay with another kind of joint, one is straight, one is not straight. Then again, we have a dummy bay area and the pipelines. Both the dummy cable and the real cable enter the pipelines. Then we go back, oops, excuse me. Then we go back to the underground station and we enter the outdoor termination bay. Even if the termination are outdoor, but the test has been performed indoor. Talking about this project, 4 manufacturers have been qualified after having passed the required type test, witnessed by independent parties. 5 cable installations comprising more than 100 meters of cable, 2 joints and 2 outdoor composite termination, each underwent a long duration test. We are used to call it pre-qualification test. Why 5 cable installation? Because one cable manufacturer participated with 2 different cable design and insulation materials, respectively. 2 test instituted has been selected by the German TSO to perform the pre-qualification test. One was JZ, now Kema Labs, and the other was 3. The request for the German TSO was to have a replica of a real underground network layout. So they want us to have cable and accessory be able to withstand each specific environment installation peculiarity, like cold temperature, we are outside and we are in Germany, cold viaducts, crossing stresses, tunnels, and so on. And for the first time, of course, we first set the highest voltage class of 525 kV DC of extruded cable system. And this has increasingly, together with the real underground situation, the level of complexity of the long duration test in terms of test modalities and management of the tests themselves. Here I can show you some picture. If you remember, I told you from the outdoor, from the cable termination, we enter the floor. We get out from here, from the floor. We are in the countryside. Here we enter a tunnel section. From the tunnel section, at the exit of the tunnel section, we have a pipeline. Then we have a vent. Sorry, the pipeline is here. Then we have a vent, a joint bay, and back to the laboratory section. This is a picture taken from a certain aid in order to show different layout. As I said, here we qualified four different manufacturers with different maximum temperature from 70 degrees to 80 degrees to 90 degrees, considering HPTE material and XLPE materials. So all of them have been qualified in different timing, but all of them have been qualified. What are our experiences during this qualification process? For example, we discussed with the German TSO, and we agreed the use of DTS, distributed temperature sensing measurement system, using optical fibers either inside the cable sheet or on the outer surface of the cable, in order to gain additional information to identify the temperature hotspot that can be in unexpected location to avoid the overheating of the cable. As I wrote here in this slide, DTS is not yet part of the standard because for the time being, both in the Great Technical Brochure and ISC standards, the only reference measurement for temperature are made with thermocouples. But we recommend the use of this DTS, since the classical temperature measurement used during a PQT is assuming that the hotspot is only or is 99% inside the duct tube, inside the pipeline. We want to increase the reliability of the test, so that's why we agreed with the German TSO to use the DTS measurement, and this have support the laboratory to discover weak point of the setup, believe me. These are some diagrams taken during real measurement. Another experience very important that we want to share with you is that after the end of the cycle, as I mentioned, we need to deliver a superimposed impulse voltage test in order to verify all the cable system. As I said, while an AC cable only withstand an impulse test, with an XLPE DC cable, the test has to be carried out with the DC voltage permanently applied and filter switching or lighting superimposed. And according to the IC 6230, there are two possibilities of coupling the impulse, either by a spark gap or by a coupling capacitors. Both procedures are quoted, but of course they have their own advantages and disadvantages. Unfortunately, so far, no clear indication is given if one of the procedure stresses if one of the procedures stresses more the cable system than the other. What we can tell you is that the use of a spark gap will discharge the energy of the cable into the impulse generator, and this is not the case when a coupling capacitor is used. A coupling capacitor causes a significant voltage drop, which has to be compensated by a higher charging voltage of the impulse generator. So the higher is the value of the coupling capacitor, the lower is the voltage drop. So in case you choose one of these two procedures, you have to take into consideration these situations. Then another discussion we wanted in the past to avoid with the German TSO was related to the visual inspection to be carried out on parts of the cable and on the accessories to be performed at the end of the impulse sections. Anyway, the IC 62A95, but also the TB 496 does not define a clear procedure for the evaluation of possible findings, change of colors, corrosion, and so on and so on. So in consequence, we recognize a lack of a clear instruction, and a list of measurable criteria can help to make the result of this inspection independent. And this, I want to stress, independent from personal experience of an inspector or judgment of an inspector. It's not possible to specify acceptance criteria for all possible deformation and changes that can be encountered during a visual inspection. So this visual inspection will always contain some degrees of subjectivity. But in the short circuit testing zone guidance for 62867, we gave a non-exhaustive list of damages, indentation, presence of corrosion, indication of possible degradation, and so on, that shall not be revealed during the examination of the sample. And we agreed of this way of doing with the German TSO. This list has been recently included in the edition 5 of 6840 in Annex J, to be more precise. You can find this STL guide. It is already been published, and the other one will be published in the next year, I hope. So I would like to conclude. Let me only drink a little bit of water again. Because the information I want to share with you now are the conclusion, and I think is very important for our tutorial. So we know that there is a growing need for electrical power, and the focus on renewable sources will ask for more miles of new power transmission lines, including underground cable. For transmission over longer distances, the HVDC technology is superior to AC technology due to reduction in losses. The market trends show that the extruded insulation technology will become the preferred one, as it can operate at higher temperature, allow for lightweight and easy to handle cable design, and is, of course, more environmental friendly. What are the main suggestions I would like to share with you? Type test itself is not enough to qualify a cable system as far as reliability is concerned. At least 40 to 60 heating cycles are needed to reach thermomechanical equilibrium between cable and accessories in the relevant interface areas. So PQ test is a must. Also, long duration test in case of direct current is a must. The installation of distributed temperature sensor are warmly suggested in pre-qualification test in order to identify temperature hotspot at an expected location to avoid overheating of the cable. PD measurement after accessory installation and during the 1 year testing are highly recommended, both in case you want qualitative information at the beginning and or quantitative information along the test. Superimposed voltage test conclude the long duration test for DC cable system only. A special care for all distances in air between components, the walls, the roof, and other components has to be taken. Due to different voltage levels, the position of maximum electrical stress changes between different configurations. As I said, it's not like the HVAC when you have only one lighting impulse, 10 plus, 10 minus, finish. In this case, we have different polarity, different voltage levels, so the distances, the clearances in air between components, walls, roof, and other components is very, very, very much of importance. And of course, last but not least, the German TSO asked to the laboratories to perform a complete loop, including accessories, the impulse section to be performed on the complete loop. So the impulse generator need to have enough energy to reach an acceptable efficiency. I think that, and this is a general statement that come to the main chase experience in the past. The successful passing of the pre-qualification test gives confidence of a new HVDC voltage level for extruded cable system with different type of cable and accessories. And this to become qualified for any 525 kV DC transmission project, not only for the German TSOs, but worldwide. In the meantime, we can easily forecast that the German TSO's procedure, the one I presented to you for the 525 kV DC qualification, will become a milestone for the HVDC market, like it happened for the 400 kV BEVA project, as I told you, for the HVAC extruded cable system in early 90s. I think this is a very big step forward, this 525 kV DC project. Of course, someone may say that there is a very low field experience coming on HVDC sector, even for lower voltage level. For example, interconnection of 320 kV are quite a few around the world. But the specific request of the German TSOs to have this higher voltage level was related to the fact that they need to transfer a lot of power from the Baltic Sea, from the North Sea, to the southern part of Germany, where the main industrial areas are. So we had a big jump, but a few years ago, we moved from this 320 with quite a few information gained from the field to this 525, and I think that it's not a secret. There is someone that is already talking about 600 kV cable system in DC. So there is a kind of rush to reach the highest voltage level, even if, and this is my personal feeling, even if a very poor experience on the real life installation. But that's another story. Okay, talking about interconnection, what time is it? I think 10 to 1. I would like to spend these last minutes of my presentation to show you some real implementation of the cables I introduced to you, both AC and DC, both land and submarine cable interconnection. The first one that was opened in 2015 is in Elfe, France to Spain interconnection. These are 320 kV DC cable. This was the first in the world of this kind of voltage. Here you can see a sketch of the cable. A sketch of the cable, you can see underground cable line. You can see some information about the XLB cable. At the time of the installation, it gained 4 world records, was the longest, that time terrestrial underground line, 65 kilometer. The one that operated at the highest DC voltage, 320 kV. The world record for power technology converter station, 1000 megawatt. And the first time for a HVDC line operating in parallel with other AC line. These are pictures taken during the laying of the Elfe and a schematic view of the converter station. This is the tunnel between France and Spain. It's only, into brackets, 8,500 meters with an inner diameter of 3.5 meters. And here you have some information about the slope and so on. But this land interconnection will be overpassed with new record of the France to Italy terrestrial interconnection. This will have a land four cables for a 200 kilometer each, so the total will be 800 kilometers. This will be commissioned at the end of this year. 2 times 600 megawatt, so 1,000 as nominal, 1,200 as overload. Then we will have also this Allegro project. It's a land interconnection between Belgium and Germany. In this case, we will have two-ways capacity between 1,000 and 1,600 and combined AC and DC. It's about 100 kilometers of underground cables, and this will be between Elia and Amphrion. Then talking about the submarine cables, of course, in this case, I put picture of a couple of the most famous vessels, one from Prysmian, one from NKT, is not a secret. These are the biggest player together with Sumitomo Electric as far as submarine cables are concerned. Let's start with one of the old, not the oldest, but one of the old, that is Sardinia Penisola Italiana, that at the time being in 2011 was named the cable of records because it was the longest cable with 1,000 megawatt power, the longest cable 435 kilometers in the Mediterranean Sea, The highest voltage level for submarine cable so far, 500 kV, and this is a critical issue, the greatest sea deep reached minus 1,650 meters. And this was posed by the Giulio Verne, was the first on the left from Prismium. And we will come back to the deep to the depth of the sea, because this is a critical issue we will discuss later on. This is the path from Sardinia to Peninsula Italiana. This first part, the cable is different, is so-called low depth cable. This one is the picture of alta profondità, means high depth. The cross section is smaller. You see, the cross section is smaller for medium to low depth. The cross and it is copper. The cross section is higher, and it is aluminum for the high depth. So here on the first part, you have the low depth cable. Then you reach 1,650 meters below the sea level. Here it's aluminum cable, and here again we come to copper cable. So when you change the material, you have to imagine transition joints, another weak point for sure. Here again, it's another cable. This is already under voltage. The name is Monita, Montenegro to Italy. It's a two-circuit of 600 megawatt, so in total 1,200 megawatt, 420 kilometer. Here you can see that again you have a situation of low depth. Then you have a kind of basin where you need a different cable, and then this is the Adriatic Sea in the middle. Then near to Montenegro, you come back to low depth again. And this is interconnected since November last year. There are some pictures taken during the laying. This is Messina 2. This is AC. This is in service since 2016. It's only 43 kilometer, 380 kV interconnection, but it's a three-phase, so in total is 260 kilometer connection. The depth is much less, 370 meters, but there are some records also for these AC submarine cables. It used a 2,800 meters of inclined galleries with a slope of 12% to take care of the different layout situation. It has a vertical well of 300 meters with 6 meters of diameter. So you can imagine how you can feel on one top looking at the downhill. And due to the fact that Sicily and Calabria, unfortunately, in Italy are one of the region where we have where we can have high strong earthquake, this cable system has been tested in Kemalev's laboratories up to 7 degrees Richter values. Here you can see this is the slope I mentioned, about 8 kilometers of this slope, and this is the well that is 300 meter depth, to take into consideration the differences in levels between the place where we reach Calabria, here from Sicily, and the earth level here in Calabria. It is 300 meters above. Another AC interconnection is Malta to Italy, again in service since 2016. This is the longest AC cables for this voltage level to 20 kV, 120 kilometer, bidirectional. All of them I presented are bidirectional. 2 independent circuits for a total of 720 kilometer. In this case, the depth is minus 160 meter. And when it happened, it connected the last but one member of EU to the European transmission system. The only one that remained isolated till now is Cyprus. I introduced this information because in a while we will discuss about another project. In the near future, we have to work in Italy for the Sardinia to Corsica to Italy connection. This was the first one put in service in 1968 and connect Sardinia, that is Italy, Corsica, that is France, and from Corsica to Italy again. But as I said, this connection is still working, but more than 50 years of age. It suffered of different failures along the years. So Terna and RTE decided to install the new 350 kV HVDC extruded cable interconnection because this whole system reached almost its end of life. And this will be installed starting from 2024, yes. Talking about Cyprus, why? Because there is a project already been financed, so-called Euro-Asia Interconnector, Israel, Cyprus, Crete, Greece, and from Greece to Italy and the rest of Europe. This is a 2,000 megawatt project, and this interconnection will exceed all records. First in the world to use 350 kV HVDC. About 1,500 kilometers in length, about 2,000 meter maximum depth, and above 3.4 million euro investment to be put in service after 2023. This is the path you can see from Israel to Cyprus, from Cyprus to Crete, from Crete to Greece, and from Greece towards the rest of Europe. This I would like to talk with you a little bit because it's very important in order to understand the complexity of submarine connection. Here, okay, the blue line is the Eurasian interconnector. You can see this will be a record for the depth that should be more than 2,000. But let's concentrate on this situation. For the BritNet interconnection is the one in the Northern Sea, that is from the Netherlands to Britain. The maximum depth over there is in the range of 10 meters. So this is a good reason, first of all, to install windmill, offshore windmill, because it's quite easy, but also to use submarine cable that do not need the complicated design of high depth situation. Again, in other sectors of northern seas, we have the West Link or the NordNet, where the maximum depth is in between 300 and 400 meters. So this situation to install windmills is a little bit more complicated if they are not floating. But for sure, cable can again be installed, of course, in case of repairing or in case of other installation, the laying conditions are more critical, but still not as critical as the one you can compare if you go in the Mediterranean Sea. In the Mediterranean Sea, unfortunately, I have to say unfortunately, we have very, very high depth. For example, the Italy to Greece is 1,000, The Italy to Montenegro is 1,300, if I remember. Then the SAPEI is 1,600, and the Eurasia will be more than 2,000, as I already introduced. Why such a big number of interconnection that we know they cost a lot of money? The reason is again economical. They cost a lot of money, but they connect but they connect Greek, for example, Greece with a very low wholesale price compared to European, with even lower prices of the Balkans to the Italian and the European area with higher wholesale prices. Distant future, I introduced Tunisia to Italy, 240 kilometers in length, maximum depth, and so on. And then the so-called Tyrrhenian link that will be put into service in 2025. Probably been a little bit too long, but I conclude my presentation. I give you back the screen. And I am ready for any kind of question you may have.
Mr. Dr. Overto. Hello.
Yes, I'm here.
I am Sanjeev Chaudhary from Power Grid, Gurgaon.
Okay.
My one query is there. This for checking the PD, you have initially told about pre-cam.
Yes.
Can you tell me up to what voltage level it will work if we go, because in our power grid we are using up to 320 kV cable. So can we use this pre-cam instrument for detecting PD in our this high voltage level? If it is used, then how it will work?
The pre-cam can be used, at least it has already been used up to 400 kV voltage level, because if you are at a distance from a cable termination, for example, you need an insulated branch to reach the cable termination and to move the pre-cam directly in front of the high voltage cable termination, because the pre-cam itself is made of plastic. The housing is plastic and can withstand, at least it's already been used with the cable system up to 400 kV.
Okay.
As I said, this is a very good tool in case you want to gain qualitative information.
Okay.
So I really suggest to use it before energizing the system. That means to verify is the work performed by the jointers is properly done.
Hello.
Yes.
Myself, Sheetal Panchal from EDA.
Okay.
Sheetal Panchal from Electrical Research and Development Association. My question is, for pre-qualification test, how cable laying conditions are there? For cable laying conditions, which standards to be referred? Because in IEC 62067, laying conditions are not given clearly. So how these cables are laid during a pre-qualification stage?
You are totally right. What we ask is that the cable manufacturer will give us the pulling strength and the pulling procedure for the laying condition. Some of the cable manufacturer do it themselves. So in this case, it's not an issue. In case they came from far away or they don't want to do it, we can do it for them, but we only apply, first of all, we only work with very well-known and qualified companies that do the same for utilities. For example, Wasserman in Germany or others in Italy and in France. So the only thing they need is the strength that the cable manufacturer has to declare to us. But you're totally right. Unfortunately, this is not included in the ISA standard. By the way, not either in technical brochure of SIGRE.
Okay.
I haven't checked if there are some questions in the chat. Sorry.
Hello,
Yes.
I am Pritam from Power Grid. Actually,
Okay.
you mentioned that for site acceptance test, we need to perform PD measurement. Can you please tell us which standard has this recommendation? I am specifically referring to DC cables, HVDC cables.
Unfortunately, when doing on site, there is no required measurement on PD according to standard, apart from some PD measurement for high voltage cable, not in AC, but not in DC. What is requested, that is not in the standard, but is relevant to different utilities, for example, Tenet, Amprion, EIA, Red Eléctrica de España, RT in France, Terna in Italy, National Grid in the UK. This request of PD measurement is only on their technical specification, not in a standard.
Hello.
Yes.
Hello. What is the life of submarine cable and what is design escape of submarine cable?
The life of submarine cable, and then I missed the second. Sorry, I missed the second question. The first was the life of a submarine cable, and the second? Okay, I will try to answer at least the first.
What is the life of submarine cable and what is the design escape of submarine cable?
The DNF. Unfortunately, I can't hear the second question. Talking about the first question, submarine cables and
design aspects of a submarine cable.
Yeah, the design life of a submarine cable is like the design life.
Design aspects of a submarine cable.
Yeah, it's about 40 years. This is the design life, 40 years, like a land cable. In principle, there is no reason why a submarine cable should last less than a land cable. To my personal opinion, it's even better because with submarine cable, you have factory joints. It means that every 30 kilometers, maybe 5, maybe 10, it depends on the vessels you charge with the submarine cable. You introduce factory joint, and the factory joint are tested in the laboratory. So you know that they are good. Then you test with the tensile bending, and you test also the mechanical. So also for the laying, they are good. And this is the main issue compared to land cables. So if we consider that land cable has a design life of about 40 years, to me, at least submarines should have the same.
Yes. Can I put a question, sir?
Yes, please.
This is C.S. Mohanty from Universal Cables Limited.
Okay.
Sir, you mentioned that VLF testing can be carried up to 100 kV. But we find after installation, but IC 60840 and 62067 does not include any requirement for that. Can you please explain?
Sorry, there was some trouble of the line. You said that up to 100 kV, then I missed the point.
Okay, but there is no testing requirement specified in IC 60840 or IC 62067.
Yeah. You are totally right. But as I said, these are requests mainly due to technical specification of the utility. For example, Terna, the Italian utility, I've been on site many times with my colleagues from Germany. Terna, anytime that there is an installation of a cable system, before accepting the cable system,
maximum conductor capacity.
they pretend to have an after laying test. That means 1 hour with a resonance system for us, or with a VLF different system, plus the partial discharge, and only if you have a withstand of the voltage and no PD measurement, they accept to have the line. This is a must.
Hello.
Yes, please.
Dr. Vato, I am Sanjeev Chaudhary from PowerGate.
Okay.
My one more query is there. Then DC extruded HVDC cable. What is the maximum size? I mean to say, what is the copper?
I can tell you what we already tested. We already tested up to 3,500 copper and up to 3,200 aluminum.
Aluminium.
500. How much is the current?
Then what is the current rating?
What is the
capacity of current rating of cable? This 3,500 cable copper.
In the range of 4,500 amps.
Commercially available?
In order to reach the 90 degrees for the XLPE material, of course.
Commercially market available.
Whether this is commercial available in market? Can you suggest the manufacturer's name?
No, I can't. No, I can't, but I can tell you that they are available.
One more query is there related to our DTS for cable.
Okay.
In DTS systems, basically in our project we are using is update in 10 minutes temperature. But in actual case, if you see overall situation of underground cable, it may take some days to stabilize the temperatures. So exactly it may be temperature higher in the conductor, but DTS will sense something may take some time. So can you explain further how this will be taken care by cable material, or because if they are telling 90 degrees coming means it was the temperature of conductor already reached earlier 90 degree, but DTS showing after some time. So this how this may be taken care by material or by manufacturers, and then and soil properties.
Is it some corresponding
You know, the issues about this delay in temperature measurement really depends on the optical fiber you are using, single mode, multi-mode, and so on. So this has to be clarified with the supplier of the optical fibers. But there is an important information that even if you may have a delay of this of the temperature you read, you have to consider that if you compare the temperature you measure with a thermocouple, maybe, I'm not sure, but maybe the reading is faster in the thermocouple than in optical fiber system, but the great improvement is that the DTS is a continuous measurement. So in case you have a thermocouple in the pipeline and another thermocouple in the bending that is 15 meters far from the end of the pipeline, you have no idea in what it's happening in these 15 meters of the cables. Vice versa, with the DTS, you have a continuous measurement. So you can accept a little bit of delay, maybe, I'm even not sure, but maybe a little bit of delay compared to the thermocouple, but a better measurement because it's continuous. Yeah.
मतलब 90 में उधर जो है इधर 70 देखा है और 80 देखा है, तो दैट मींस यहाँ पर 80 रीच कर दिया ये दर्शन ऐसे ही करके तो कर देगा। अरे
कैलिब्रेशन
जैसे यहाँ पर 90 हो गया,
So any
यहाँ पर
other
80 देखा है, तो
Vishan ji?
Converted to
Hello, sir. I am RB Lakhantra from JETCO. Which cable is more better, XLP or aluminum corrugated?
It depends on your final use. It depends on your final use.
And
It's
which
not
type of termination?
it's not like it's black or white. You need to give me some information about your connection, and then I can answer.
In a coastal area.
नाम तो नहीं बोला डॉक्टर।
Hello.
Yes.
Which type of termination?
This is Himanshu Joshi from ERDA. I want to ask about the tan delta measurement.
Okay.
Ambient temperature.
You know, tan delta measurement is a very good measurement in case you want to have an average information of the health of your connection, but give you no information at all on the localization of the point.
Any thermal तुम्ही बोलो heat dissipation proper or not पता है।
Okay.
Dr. Bhatto, one more query from Power Grid, Sanjeev Chaudhary this side.
Sorry, say it again.
Our query is that in case of hilly terrain where the ambient temperature is minus 20-25 degrees Celsius.
Okay.
Okay, now for how this for the land cable, how this heat dissipation will be will be taken place.
How it is
But you mean you want to have an idea about what happened during the laying condition or during the testing of cables to simulate such a temperature?
During operation.
During operation, you may have minus 20 degrees outdoor, but in 1.5 meter underground, the temperature should be around 10 degrees plus.
Surface. No, on the surface, not underground.
Not underground, sorry.
Yeah.
Not underground. It's a difficult issue, of course, but how you keep this cable on the open air? High voltage cable.
Concrete duct bank.
In concrete duct bank in hilly terrain.
Okay, so you think that the temperature in concrete duct can reach minus 20?
Yes.
Quite difficult situation, I have to say. I have no experience on that.
Dr. Vato, can you share this experience later on? No issue.
I will check with my colleagues. Maybe in Germany they have a situation of this kind. I will let you know. Just send me a mail with your references.
Yeah, I request all of you, please send your queries to Tigre India so that they will connect with Uberto and reply all of you.
Okay.
Doctor, I have got a question. Hello.
Yes.
IC 62895 only specify the upper limit of the voltage there, that is 320 kV.
Yeah. You are totally right. I am one of the faulty guy. In reality, I'm not faulty at all. When we prepare this standard, the 525 project was not yet designed. So when we have finished, because you know that a process to write a standard can take from 3 to 5 years. So when we published the 62A95, that you're totally right, it's up to 320. This was supposed to be at the state of the art. Nowadays is no more the case, but we already started the discussion within the same members who prepared the 62A95 to prepare a revision including 500 kV cable system. But we are waiting for SIGRE B1 to give us guidance on that.
Dr. Vato, sir, one more query in our, especially in DC cable, HVDC cable. There is no measurement of PD. Even our SIGRE TV 496 is not mentioning about the PD measurement. So whether in new IC or new, there's some inclusion of measurement of PD?
As I said, I was one of the people who prepared the 62A95. I have honestly to say that we discuss a lot if or not to introduce PD measurement and which kind of PD measurement. At the end of the discussion, there was no consensus. So as most of the time, whenever you publish a standard, is an equilibrium between some ideas and other ideas, some needs and some against some solution. So we decided to publish for the time being without any PD measurement and leave the utilities like Tenet, like Amprion, like Terna, and so and so, to introduce their own requirement inside the technical specification. But I can promise you that I will come back again for the next revision, trying to push for this measurement.
Okay, but during your presentation, you were or I already discussed this PRI-CAM or PD measurement equipment, which can be used up to 400 kV, because we are going to our site testing, our system. This what is the cost of this equipment, and this easily available in market? Even we want to do
I can answer the second question. It is easily available in the market, but I have no idea about the cost. We bought ourselves, but I don't remember because I was not the one who paid. So I know that we have some, but I don't remember the cost. If you wish, I can please send me a mail and put you through the organization who can deliver you a quotation, but I don't have it.
Okay.
Okay, ladies and gentlemen, is there any other question? If not, I will say goodbye to everybody. I thank you for all the attention, your nice question. I will try to answer all the remaining ones by email.
Uberto, thank you
Hello.
very much.
Hello.
Yes.
Testing.
Hello, Mr. Uberto. This is Anupam from KA Industries.
Okay.
Sir, thank you for the presentation, first of all. Secondly, is there any way I can get connected to you, like LinkedIn or something else, social media?
You can find myself in LinkedIn, but also my email address is very easy. Vercellotti, that is my family name, at cesi.it.
Okay, got it.
Okay.
Thank you so much for the presentation, sir.
My pleasure. It was a real pleasure, and I look forward to meet all of you in India next time.
Thank you, Uberto. Thank you very much.
Take care.
Thank you.
Bye-bye.
Thank you.
Thank you, sir.
Bye-bye.
Thank you.
Bye, Mr.
Thank you,
Rose.
sir.
Bye.
Bye.
આવજે ભૂરા.
Thank you.
डिसमिस कर दो.
ऑटोमेटिकल डिस्कनेक्ट हो जाएगा ना, एग्जिट नहीं है क्या?
डिसमिस से ही होता है एग्जिट या
ये तो वो सब का आ गया. हम लोग का
ये है ना.
नहीं, हमारा ही है. बट एग्जिट कहाँ है? एग्जिट ये क्या मीटिंग नाउ?
Hello. 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 Can anyone share Mr. Uberto's email ID? Hello.